Okay, Chapter 12 is interpreting prescriptions and converting household and metric measurements. So after reading through this chapter, which I want you to read through this chapter, after reading through it, the student should be able to describe the metric system, identify the standard metric units for length, weight, and volume, define prefixes used in the metric system, perform conversions between the metric system and household measurements, perform conversions within the metric system, interpret common pharmacy abbreviations. So doctors order medications for outpatients as prescriptions, of course, that are going to be filled in the pharmacies. Information is provided in the prescriptions in a standard way. So to perform necessary pharmacy calculations associated with filling prescriptions, two parts of the prescriptions are going to be essentially important, and that's going to be your inscription and the SIG. You need to know those abbreviations. So there are abbreviations on page 88 as well that you need to memorize as well too. So I'll make a note on here for that. Most of these will just be a review for you. Those common pharmacy abbreviations are in table 12.1 on page 88. Make sure you memorize those. The description, of course, gives the name of the medication and the amount to be dispensed. The SIG provides the instructions for use. Other elements of the prescription are going to be required by law and are beyond the scope of this book. So it is important for the pharmacy technician to know the common abbreviations that are going to be used in prescriptions. And of course, some common pharmacy abbreviations are listed on that table 12-1. And it gives you an example prescription above that table on page 88. First, if you turn to page 89 in your book, it talks about converting measurements. So medications are going to be prepared by drug manufacturers according to the metric standards and measurements used in the science. Pharmacies have an important duty to accurately convert your metric measurements for the dose of medication to household measurements to ensure that patients get the correct dose of medication. So the pharmacy label should provide information so the patient can read the instructions on the prescription bottle measurement, measure the correct dose of the medication, and take the correct dose of medication. Um, if you look over on this chart here on page 89, that it shows you the household measure and the metric equivalent. Make sure that you memorize this chart, okay? Along with these items here, 1 kilogram is equal to 2.2 pounds. Make sure you memorize that. And this down here, I gave you this little shorthand below last semester. So anything that says kilo, if you're doing conversions, so kilogram would be 0.001. It don't matter if it's kilograms or kiloliters. 1 gram, 1 liter. This is just a conversion table. 1,000 would be milli, and micro means a million. So 1 gram is going to be equal to 0.001 kilograms. It's also going to be equivalent to 1,000 milligrams. And it's also going to be equivalent to 1 million micrograms. Okay, so if you look on page 93, what they're doing is you're just converting, okay? So number one, if you notice, is asking you to convert 1/3 teaspoon into milliliters. Okay, and we can't convert this until we put this 1/3 into decimal form. Okay, so if you take your calculator, divide 1 divided by 3, that's going to come up with 0.33. Okay, so I tell people all the time you could go ahead, just use it the way it's set up. We're going to do our cross method like this, or you can write it down below. Okay, for today I'll write it this way because this is like it tells you that we have 0.33 teaspoons. Okay, and we're wanting milliliters because it's already over here. Okay, and then so if you have teaspoons in this corner, you have to have teaspoons down here. Okay, and then what we do is we look at our chart that we just memorized, And we see how many milliliters equal to how many teaspoons. So we know that 5 milliliters is equal to 1 teaspoon. And I'm getting that information from the table in your book. Okay, so then all we do with this one, we're not going to cross multiply on this one because our units aren't the same on the top and they're not the same on the bottom. So we're just going to multiply across then divide. So 0.33 multiplied, of course, by 5 is going to be, 1.665 over 1. So your answer, if we rounded this to the nearest hundredth, would be 1.67. So 1/3 teaspoon is equal to 1.67 milliliters. Number 2, you have 3 teaspoons is equal, and some of these you can figure up in your head, but I'm still going to use the formula just so you get used to the formula. So it's equal to how many milliliters? Okay, so you use your formula, and we're just really taking this and dragging it down in that top two number areas. With the conversions, you don't ever put anything in this one side. So 3 teaspoons, and then you have your blank milliliters. So we have milliliters, and if we have teaspoons up here, we need to have teaspoons underneath. Okay, we look in our chart, we see how many milliliters is equal to how many teaspoons. So 5 milliliters is equal to 1 teaspoon. Okay, then you just multiply across and then divide. So you have 3 times 5 is 15. 1 divided by nothing is 1. So it'd be 15 over 1. So it'd be 15. So 3 teaspoons is equal to 15 milliliters. Next, number 3, you have 2 pints is equal to blank milliliters. Again, our little handy dandy cross here, or plus sign. Mark that one out. And we know we have pints here, and I'm just going to abbreviate with a P, milliliters here. If you have pints here, you're going to have pints here. Okay, so you're going to have 2 pints, and then we need to find the numbers for the milliliters and pints. So we look in our chart, and in our chart it tells us that 1 pint is equal to 473 milliliters. Okay, and then we just multiply across, so 2 times 473 will be 946 milliliters. Divide by 1, your answer is going to be 946. Number 11 is asking you 3 fluid ounces is equal to blank milliliters. So we do our cross. Nothing goes in this far corner. You have 3 fluid ounces here, ounces will go here. Fluid ounces, same thing as ounces. And then you have milliliters here. So then we look in our chart, and of course you can use the most specific number or the rounded version. And the answer back in this booklet, they used the more specific one. So you had 29.6 milliliters is equal to 1 fluid ounce. So then you take 3 multiply by 29.6, and you get 88.8 divided by 1. So then your answer would be 88.8. Okay, now some of these, this is doing the easy cross, just the one cross. Okay, sometimes you may need to go take this cross out several times. So I'm going to give you an example for two examples on that one. So number 33, you have 0.908 kilograms is equal to how many pounds? Okay, so this is equal to how many pounds? Okay, now we could do this one two different ways. I'm going to show you the long version. I know I gave you the one thing to memorize, of course, that you have 2.2 pounds equals 1 kilogram. But we're going to pretend like we don't know that. So we're just going to look at the regular chart. Okay, so we're going to do a long one here. So we look in our, we have 0.908 kilograms, and we want pounds, but we look at our chart, the one chart, and we don't have kilograms to pounds. So then we take it to, we want to keep it in the weight category. So we know that 0.001 kilograms is equal to 1 gram. Okay. Then if you have grams here, you have to go again, put grams here. And we're trying to get to pounds. So if you look at your chart, you know, of course, 454 grams is equal to 1 pound. Okay. So then all you do is multiply across. So 0.908 times 1 times 1 is going to be 0.908. And then you're going to take 0.001 and multiply it by 454. And you get 0.454. And then when you divide that, you come up with 2. Okay, so the 0.908 would equal 2. Now, if you was to work this out with the, 2.2 pounds is equal to 1 kilogram, then you would come up with an answer of 1.99, like 76. You would just round that to 2. Okay, next, number 34, conversion. You're going to convert 3.785 liters to gallons. Okay, so we know we have 3.785 liters. You have liters here, you need liters here. And we want gallons, but our chart doesn't go from anywhere from liters to gallons. So, but we do know that 1 liter is equal to 1,000 milliliters. And then we know milliliters will go to gallon. So milliliters here, we have milliliters here, gallons here. Okay, so if you have, you look in your chart and you know 1 gallon is equal to 3,785 milliliters. So then we just multiply across on both sides. So 3.785 times 1,000 is going to be 3.785. I'm sorry, I mean 3,000, oops, 785, not 3 point. So 3.785 times 1,000 equals 3,785. And then 1 times 785 will be on the bottom. And you divide that and you get 1. So your 3.785 liters would be about equal to 1 gallon. Okay, number 41 through 45 is asking you pretty much to find, of course, the missing thing, but you're going, or missing dose. But what you're going to be doing is setting up a ratio proportion, and then one of those numbers on the ratio proportion you may have to convert first. Okay, so if a number 41, if a Rx reads cephalocore 250 milligrams per 5 milliliters, that's going to be part of your ratio proportion. Dispense 150 milliliters. That's just telling you how much to dispense of the medicine. The doctor wrote the prescription note for 375 milligrams twice a day for 10 days. What is the dose in teaspoonfuls? Okay, so what we will do first is set up our ratio proportion. So we know 250 milligrams over 5 milliliters, and we have 375 milligrams is what the prescription is written for. Okay, so we need to know what dose to give. So we put X, and we want to find it in teaspoonfuls. So I'm going to give you a little hint that when you're doing the ratio proportion, your units on top have to match. If they're both, they have to match two ways. If they're both weights, you can't have a weight in a liquid up here. You have to have like two weights. So milligrams and milligrams or milligrams and grams. Okay. Then they have to be exactly the same unit. So if it's not if this would have been gram, we would have to adjust that. So both of these are okay because they're both milligrams. They're both weights. Down at the bottom, we have two liquids, so that's good. But it's asking for the answer in teaspoonfuls, not milliliters. So now what we're going to do is we're going to convert 5 milliliters to teaspoons. And you can set this up in your conversion cross if you wanted to, or this one's an easy one. We know 1 teaspoon is equal to 5 milliliters. Okay. So then you have teaspoons and teaspoons. So now we're good to go. So now you cross multiply. So whatever we multiply the x by goes on the bottom. So 250 is going to go at the bottom because it's multiplied by x. And then you have 375 multiplied by 1 is 375. So then, of course, you take 375, divide it 250, and you get 1.5 teaspoon. Now, I have seen some people just go ahead and do the ratio proportion out, and then they convert the answer over at the end, and you can do that, but to me that's more confusing. So if you have everything lined up at the beginning and then work it out, then you're good to go. But the main thing is to know is to make sure that both your units on the top match, both the units on the bottom match. Okay, so number 42, if a prescription reads erythromycin, 250 milligrams per 5 milliliters, and I'm going to go ahead and I always like to tell people, like when you read it, circle what you know is going to be part of your ratio proportion or what you think it may be. So erythromycin, 250 milligrams per 5 milliliters. They're going to take 200 milligram 3 times a day for 5 days. What is the dose in teaspoonfuls? Okay. And this was actually an easy one to figure out in your head, but I'm just going to use the formula. So 250 milligrams over 5 milliliters. And we know we have 200 milligrams, and it's going to be on the top because we want our units to be the same. So we have milligrams here and milligrams here, so we're good to go. And then we're looking for, or what we're finding, is teaspoonfuls. So it'd be X teaspoon. Okay, so we do have two liquids on the bottom, milliliters and teaspoonfuls, but we're finding for teaspoons, so we're going to change this, and we're going to convert it over, so it'd be 1 teaspoon. So 5 milliliters is equal to 1 teaspoon. Okay, next you're going to cross multiply 250. Oh, I'm sorry, that's supposed to be 200. I apologize. Let me correct that. Oops, I wrote the prescription down wrong, or the question down wrong. So if a RX reads erythromycin 200 milligrams per 5 milliliters, and they're to take 200 milligrams per 3 times a day for 5 days, what is the dose in teaspoonfuls? So 200 milligrams over 5 milliliters will be here. And then you'd also have your other 200 milligram here, and we're trying to find X teaspoons. Okay, I apologize about that. So then we're going to cross multiply, and 200 multiplied by X goes on the bottom, so you have 200 X, and then 200 times 1 would be 200. Okay, and so your answer is going to be 1 teaspoonful. Okay, I'll do another one because I want to save some for y'all to do, so there's not that many on here to do. So number 43, I'm not going to write this prescription down. I'm just going to read it out of the book. So this is on page 96. So if the dose of a medication is, and I'm going to write it down as I know the numbers we'll need, 30 milligrams per kilogram. If it just says per, like that, it doesn't have a number, you always assume it's going to be a 1. It's always a 1, okay? Okay, so 30 milligrams per kilogram per day in 4 divided doses. Remember that for later. What is the dose for a 205-pound patient? So use, of course, your 2.2 pounds per kilogram to do. So we know we have over here X. So we're going to find, of course, how much the dose is. What's the milligram? And the patient, of course, weighs 205 pounds. We put it on the bottom because we know that our kilogram conversion to pounds. Okay, so this was one I would have to set up a cross for. And I'm going to do it down here at the bottom. I always do mine down somewhere where you can't find it. We have milligrams here. We're trying to find the X milligrams here. Okay, kilograms here, but we need to convert this over to kilograms. Or you could do the 1 kilogram. We could switch it to pounds. Either one. Okay. But I'm just going to do the harder one just to show you. 205 pounds. Pounds up here. You don't have pounds down here. And we're trying to find kilograms. Okay. So remember 2.2 pounds is equal to 1 kilogram. And again, we could have easily just changed that to pounds and they did 2 pounds on the bottom, but I'm doing this out longer the other way just to kind of show you, how to work it out. So 205 divided by 2.2, and you get 93.18. So 93.18. So on this one, that's kilograms. This one, you could have converted kilograms to pounds as long as the two bottom ones are the same. You have pounds, pounds. Or you could convert the pounds to kilograms and have kilograms on each one. Okay. So just to let you know that you could have done either one, the answer will still come out correct. Okay. So then you're going to cross multiply. X times 1 goes on the bottom. 30 times 93.18 is going to be 2,795.45. Okay, and then of course that's over 1, so it's going to actually be the number. So it's 2,795.45 milligrams. But then if you remember, it gives us a hint that there are 4 doses per day. So it's wanting to know what each dose is. So then we will just take this and divide it by 4. So 2,795.45 divided by 4, you're going to get 698.86 milligrams. Okay, and that'll leave you number 44 to practice with and 45 on those. Your answers are in the back of the book. If you have questions or need me to help you work through those, just let me know. This one, and that's why they just gave you a 5 to get you started on those. You may see more of these later on in this calculations book. Okay, so that's all for chapter 12. If you have any questions or concerns, please stop by my office during my office hours. In the Lab 107, tutoring people for the pharmacy classes or anatomy from 10:30 to 11:30 on Wednesday. So you're welcome to come into Fincastle Hall Lab, room 107, if you need additional help.